welcome to True Projects. In this video, we are going to explain about the project, which is aspect-based Twitter sentiment analysis on vaccination and vaccine types in COVID-19 pandemic with deep learning. The COVID-19 pandemic prompted the rapid development and deployment of vaccines worldwide. It became crucial to gauge public sentiment towards vaccination efforts and vaccine types to address potential challenges. The project is centered around conducting sentiment analysis on Twitter data related to vaccination and various COVID-19 vaccines. It involves the use of deep learning techniques to understand and categorize the sentiments expressed by Twitter users. The project aims to tackle issues such as vaccine hesitancy and misinformation by providing valuable insights into public sentiment. It seeks to contribute to the efforts of vaccine development and community vaccination campaigns by addressing trust and perception issues. The main goal of the project is to conduct aspect-based Twitter sentiment analysis on vaccination and vaccine types in the COVID-19 pandemic using deep learning techniques. The project employs several deep learning algorithms which are MBERT, BioBERT, Clinical BERT, BERT-Turk, LSTM, CNN with LSTM, CNN with GRU. These algorithms are used for sentiment analysis, which allows the project to categorize Twitter data into sentiments related to vaccination and vaccine types. Deep learning models excel at understanding complex patterns and context in textual data, enabling more nuanced sentiment analysis. The ultimate goal of the project is to address challenges related to public trust and perception of COVID-19 vaccines. By analyzing sentiments, the project aims to identify factors contributing to vaccine hesitancy, uncover patterns of misinformation or distrust, provide insights for policymakers and healthcare professionals to tailor vaccination strategies. There are hardware and software requirements which are needed for implementing the project. Hardware requirements. In that, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. In software, we need Anaconda 3 and Visual Studio Community version. In the flow of work, we have designed few modules to implement the project. The first one is importing the packages. This module involves importing the necessary libraries, which are NumPy for pandas, NumPy for numerical operations, pandas for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for visualization, scikit-learn for machine learning, transformers for natural language processing. Exploring the dataset. This step involves the exploration of the project dataset, where the data analysis is done for the structure, content, and statistics of the data. It helps in gaining an initial understanding of the data before further processing. Visualization using Seaborn and Matplotlib. In this module, Seaborn and Matplotlib are utilized to create data visualizations such as histograms, scatter plots, and bar charts. These visualizations aid in understanding data distributions and patterns. Data processing. This module involves several data processing tasks including removing lowercase, punctuation, and special characteristics from the data. Eliminating multiple consecutive spaces to ensure data consistency. Remove stop words. The commonly removed stop words are and, the, is. These are to reduce noise in the data. Tokenization. In this step, two tokenization techniques are applied in the text data. The first one is BERT tokenism. Tokenization is specific to the BERT model. Keras tokenism. Tokenization using Keras typically employed in the neural network models. Random oversampler. This module involves addressing class imbalance in the dataset through random oversampling technique, specifically using one-hot encoder. It helps to ensure that the dataset has balanced representation of the different classes. Feature selection using Pandas iLog. Here, feature selection is performed using Pandas iLog, which allows for the selection of specific columns or features from the dataset. This step helps in choosing the relevant input features for the model training. Building the model. This module encompasses the creation of various deep learning models including MBERT-based, which is multilingual BERT. It is a pre-trained transformer-based language model developed by Google that can handle multiple languages. It is used to analyze sentiment in multilingual Twitter data, ensuring the project can process tweets from different countries and languages effectively. BioBert, which is a variant of BERT fine-tuned for biomedical text, making it suitable for healthcare-related sentiment analysis. It is employed to analyze sentiments in healthcare-related tweets, ensuring that medical and health aspects are appropriately considered. Clinical BERT. It is a BERT model fine-tuned specifically for clinical and medical text. It is utilized for analyzing sentiments in clinical and medical context within tweets, ensuring the accuracy of sentiment analysis in these domains. BERT Turk, which is a Turkish language specific variant of BERT, tailored for Turkish text analysis. It is applied to analyze sentiments in Turkish language tweets, addressing the specific language nuances and characteristics. LSTM, which is long short-term memory. It is a type of recurrent neural network known for handling sequential data with long-range dependencies. LSTM is used to capture the sequential nature of the text data in tweets, allowing the model to understand sentiment based on the order of words. CNN with LSTM. This model combines convolutional neural networks and long short-term memory networks, leveraging CNNs for feature extraction and LSTMs for sequential analysis. The combination of CNN and LSTM is employed to capture both local and sequential patterns in the tweets, enhancing sentiment analysis accuracy. CNN with GRU. This model combines convolutional neural networks and gated recurrent unit networks, using CNNs for feature extraction and GRUs for sequential modeling. It is used to efficiently capture local text features and sequential dependencies in tweet data, improving sentiment analysis results. Training and building the model. In this step, the deep learning models are created in the previous module are trained on the pre-processed and tokenized data. Model training involves optimizing model parameters to make predictions based on the input data. Flask framework with SQLite for sign-up and sign-in. This module sets up a Flask web application with an SQLite database for user sign-up and sign-in functionality. It allows users to create accounts and log in successfully and securely. User gives input. In this module, user provides input in any language through the web interface. The input is subsequently processed and prepared for sentiment analysis. The given input is translated and pre-processed. This step involves two substeps, which are using Google Translator to translate users' input into a common language for analysis. Using Keras transformation for text cleaning is performed on the translated input to ensure consistency. Trained model is used for prediction. After translation and pre-processing, the input is fed into the previously trained deep learning model to predict the sentiment. The model's predictions are based on the user's input. Final outcome is displayed through frontend. The final sentiment analysis results are displayed to the users through the web frontend. Users can view the sentiment expressed in their input text, aiding in understanding public sentiment regarding vaccination and vaccine types. For execution of the project, first we need to open the code folder which contains the source codes. This is the static folder. This folder consists of the CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the model file which contains algorithm information, and this will be loaded into the project code during runtime. And this is the notebook.ipynb file. This is the Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for the data science. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the path of code folder from the address bar of the file explorer. So we will copy this. And now we will open the Anaconda prompt. Using the cd command, we need to paste the copied path and click on enter. By this, the current directory is changed to the code folder's path. Here we need to type python space app.py. This will compile app.py file, and this will execute Python script and perform a runtime check for any syntax errors or logical issues. Now we will click on enter. After running the app.py file, The Flask framework will host the application locally at the default address, which is localhost, and the port number, unless configured differently. And this is the port number and this is the localhost. Now we need to copy this local link provided by the Flask framework and copy it in the any web browser. So we will copy in Google Chrome. So here we will paste the link and then click on enter. So this has redirected to the home page of the project, which is displayed in the browser. And this front end is built by using the Flask framework. Now we need to click on sign up. Here we need to enter the registration details if we are registering newly. I have already registered, so I'll directly click on sign in. So here I need to provide my username and the password and click on sign in. So here which we can see the input text box, here we need to give the message. For that we will have the predictions whether the text is positive, neutral or negative. So here we will give the tweet. I entered the message here, now we will click on predict. So it is predicted that the sentiment of the text is negative. Now we will give another text. I gave the text here, now we will click on predict. So it is predicted that the sentiment of the text is positive. Now we will give one more text. I have given the text here, now we will click on predict. So it is predicted that the sentiment of the text is neutral. In this way we can give any text, for that we will have the predictions. Now we will sign out. Conclusion. The sentiment analysis of Twitter data across multiple aspects of vaccination revealed a diverse range of sentiments with variations observed among different countries and aspects. Deep learning models including BERT, MBERT, BioBERT, Clinical BERT, BERT-truck, LSTM and CNN-based architectures effectively categorized sentiments in the Twitter data. Some models outperformed others, demonstrating the versatility of deep learning techniques in sentiment analysis. The project's findings have significant implications for public health initiatives. By identifying sentiment trends and addressing concerns, it can contribute to strategies aimed at improving vaccine acceptance and uptake during the COVID-19 pandemic. As a pioneering effort in understanding public sentiment towards vaccination during a global health crisis, this project paves the way for future research. Policymakers can use these insights to tailor communication strategies and public health campaigns to address vaccine hesitancy and improve overall vaccination rates.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.